Hey guys, and welcome to the notes today. Today's notes are going to be on chemistry, so this is the start of chapter 2. So today we're going to first talk about what are the smallest objects that make up the substances that you see here. So you have salt, you have Gatorade, you have the earth, you have even living things, you have diamonds, you have people. What do they all have in common? So we're going to look at the substances that make up this, little tiny particles, and talk about how they work. Okay, so the first thing I want to talk about is what is an element. So an element is matter composed of one type of atom. All right, so atom obviously are the smallest substances. We'll get to that in a moment. Elements are the other building blocks of substances. All right, so these come together to make everything that we know. So where do we find information about the elements? Well, the backbone of chemistry, which is called the periodic table of elements. Okay, so you notice this one shows 103. We're actually up to 119 currently named elements. Okay, so some of these are found in nature. Some of them are actually made in labs, basically. All right, that's why we're up to 119 now, because some of them were synthetically made in places like Brookhaven National Lab, right? So right down the road here, they're actually making other elements. Okay, so what is an atom? So atom actually are the things that make up the elements. So it's the smallest part of the element. It has the characteristics of the element, and the parts of that, okay, which you may be familiar with some of these terms already. Nucleus. Nucleus is the center of the atom, just like it is the center of the cell. So nucleus is protons and neutrons. Okay, so those are the bigger subatomic particles that make up the atom. And then the smaller stuff that actually is moving around the nucleus. So first off, we have the electrons out there. So the little actually particles that are yellow there are the electrons, and they tend to orbit around the nucleus. And they show it as a perfect orbit here now. Now we figured out that it's more like an electron cloud, what they call it. They do move around, and they move around pretty not so regular as this. Okay, so it might be a little more chaotic than they're showing. There are shells, all right, so a certain amount of electrons in each little shell. All right, these shells also can, like I said, house the electrons, okay, on the outside of the atom. Okay, and this symbol you might be familiar with for the atom, all right, you might have seen it on Big Bang Theory, the show. Right, you see the basically chaotic moving around, so that's to show you the cloud model. But they do orbit around the nucleus because the electrons are the particles that do that. Okay, now how do we actually describe these three subatomic particles we just talked about? Okay, so a proton is a positive charge, and that's found in the nucleus. Okay, neutrons are neutral. Okay, some people say neutrons, they mess that up with negative charge. Be careful. Neutrons are neutral. And nucleus is where it's found also. And electrons are negative, and again, outside the nucleus in the area called the orbital or the shell. All right, so that was the term that also can be used for the outer part of the atom. Okay, and the way to remember this, all right, be positive like a proton. It's one little thing I remember. And then the other joke is a neutron walks into a store and he basically gets away with no charge on the item. So just a cheesy little joke, little dad joke for you. All right, so no charge for neutron. And then electrons are negative, so just remember that. Okay, characteristics of the atom. Atoms are always in motion. Okay, just like any particles in the universe, all right? They're always in motion. They have higher temperature than what's called absolute zero, so therefore they are in motion. All right, higher temperature equals more motion, obviously. Nucleus contains the protons and neutrons. The electrons surround the nucleus, and there's an equal number of protons and electrons if the atom is neutral, meaning it has no charge overall. So we'll look at a couple of charge examples, but in general, usually most elements are going to be neutral, and the reason why, because the protons are equal to the electrons. The two charged particles equal out. Okay, here's an example of how to read the periodic table. All right, so the atomic number is the number of protons, so that's the numbers that the actual chart is counting by. All right, so this carbon here is actually element number 6, atomic number 6. So that's the number of protons, 6. Atomic mass is how much matter's in the element. They will show you the exact number here, which is 12.01. We're going to use that number rounded typically, so round to the nearest whole number. So in this case, it will be 12 atomic mass units. All right, and that's the units for the atomic mass. The first letter of the symbol will always be capitalized. Okay, if there is a second letter, it will end up being lowercase. So in this case, this is just a one-letter element, carbon, which is a capital C. Some other ones like sodium, Na, will be a capital N, lowercase a. All right, and that's the way that works. Okay, also important on the chart are some stuff that we should know. So there's certain groups on the chart. So the first group all the way to the far right on the periodic table is called the noble gases. They are inert, meaning that they do not react with other elements. So make sure you know that word inert, I-N-E-R-T. Okay, so they don't react with other elements. They don't want to combine with anything chemically. They just kind of exist on their own. An example of that is helium or neon. Metals. There's a zigzag line I will show you towards the right side of the chart. Metals are on the left side of the chart, left of that zigzag pattern. And what are their characteristics? They're shiny luster. They tend to be solid. They are malleable, meaning they can be hammered out. Ductile, they can be stretched out if they're heated up. And they're good conductors of heat and electricity. All right, so used for electricity transmission sometimes, or heating up substances. So they're good for making sometimes cooking stuff. But again, certain metals are better than others. Certain metals are toxic, so we have to be careful of that also. Non-metals are on the right side of the zigzag line, and they're exactly opposite of the metals. So they tend to be dull, brittle, meaning they're breakable, they crumble a little bit. Poor conductors of heat and electricity, so they kind of don't like to do what metals do. And then metalloids, lastly, which I laid out which ones they are the zigzag line. So that's boron, silicon, germanium, arsenic, antimony, and tellurium. They're on basically this zigzag pattern, which I'll point out in class on the document for that. They have properties of both metals and non-metals, so they don't really take a side. They're kind of the people in the middle. Think of them that way. So they're neither metals nor non-metals, but they take properties on of each of those in some sort of mixture. And here it is, and this is what I was talking about. So here is the zigzag pattern going down, right? So you can see it right here. Okay, just like I discussed. So we'll look more at this. I'm going to give you a copy of this so you guys can actually look over, and you're going to be identifying elements. You're going to be figuring out some stuff with this chart. So we're going to go over that in a future video. All right, thank you guys for tuning in, and that's it for the intro to chemistry.